Hello and welcome to part 3 of our discussion on polynomial. This is still on Commerce Online Academy, and in this part we are going to look at more examples of division of polynomials. We are actually going to look at more advanced examples. Now before I go into details, let me recap the rules involved in division of polynomials. In the previous class, I said that if we want to divide polynomials, three things are always involved. Number one is dividend, which is what we are dividing, the polynomial that we are dividing. Two is divisor, which is the polynomial that we are using to divide. And three is the quotient, which is the answer we are getting after the division. Now, the division process or the whole division process of polynomial involves three things. First is to divide, second is to multiply, and third is to subtract. The division involves dividing the dividend by the divisor. The multiplication involves multiplying the quotient by the divisor, and subtraction involves subtracting the answer gotten after multiplication from the dividend. Now please note that whenever we see any polynomial and we want to perform arithmetic with it, the first thing to do is to arrange the terms in the polynomial according to their descending order based on their degrees. In the previous class, we talked about the degrees of polynomial. That is the highest power of the variables in the polynomial. So when we see polynomials and we want to divide, the first thing we have to look at is to make sure that the terms are arranged according to their descending order based on the degree of their variables. For instance, if we have 2x raised to power 3 plus 4x raised to power 2 minus 1. If you have 2x raised to power 3, 2x raised to power 3, 4x raised to power 4 minus 1, what we are going to do is to arrange this in the descending order. That means that this one that has higher degree will come first, followed by this. So we're going to have 4x raised to power 4 plus 2x raised to power 3. Now there's something we always do here. We must make sure that the order of the arrangement follows from the highest power continuously to 0. That means after the fourth power, we have third power. We must have second power, whether it is included in the polynomial or not. So far we want to perform an arithmetic with it, we must always include it, especially if we want to do division. Now what this means is this: since nothing carries a variable with power 2, we are going to introduce it. We are going to force it into the polynomial. And how do we do it? We know that anything multiplied by 0 is 0. Therefore, if we introduce x raised to power 2 and put a coefficient of 0, it will make the whole thing 0. But let it be in that expression. So we are going to have plus 0x raised to power 2, then minus 1. This is very, very important if you are doing division with polynomials, especially if you want to solve advanced polynomials. If you want to do division with advanced polynomials, this is very, very important. Now, let's look at some examples. Example 1. Now, assuming we have x raised to power 3 minus 4x raised to power 2 plus 2x minus 3 then divided by x plus 2. Now, how do we solve this polynomial? How do we do this division? We are still using our long division method. We arrange it. First, we check if the terms in the polynomial are arranged according to the descending order of their degree. We have raised to power 3 here, power 2 here, okay, power 1 here. Okay, so this one is arranged in descending order of the degree. So we don't have any work to do there. Now we start with our main division process. We put the dividend inside the box. 3 raised to power 3 minus 4x raised to power 2 plus 2x minus 3. Now outside the box, we put the divisor x plus 2. Now in dividing, we pick the highest degree in the divisor and use it to divide the highest degree in the dividend. Now this one just has 1 degree in the divisor, which is x raised to power 1. So, and in the dividend, the highest degree is x raised to power 3. So we are using the x to divide the x raised to power 3. So we are going to have x raised to power 3 divided by x. What it means, just remove the number of x here from this based on the law of indices. That is going to give us x 3 minus 1, which is x raised to power 2. So we have x raised to power 2 x raised to power 2. Now we use these quotients to multiply the divisor, the terms in the divisor, all the terms in the divisor. That is, we use it to multiply x and we use it to multiply 2. So we are going to have x raised to power 2 multiplied by x. We have x raised to power 3, x raised to power 2 multiplied by 2. We have plus 2x raised to power 2. Now watch this, that each one must be under the degree that is alike with it, that is similar to it. That is x raised to power 3, it has degree of 3. So it must be under the value or the term in the dividend that has degree 3. Now x raised to power 2 must be under the term in the dividend that has the degree of 2. X raised to power 1 must be under the term in the dividend that has x raised to power 1 or that has degree of 1. So that is how we arrange it. Now, having gotten this, we have multiplied all the divisor. Now we do subtraction. We draw a line and subtract. X raised to power 3 minus x raised to power 3, we are going to get 0. Minus 4 minus 2, we are going to get minus 6. So we have minus 6x raised to power 2. Now we bring down the other terms. Plus 2x minus 3. Here again, we use the power, we use the first term in the divisor, that's the one that has the highest degree, to divide the highest degree in this one that we got now after subtraction, in this quotient that we got after subtraction. So what we are going to have now is 6 minus 6x raised to power 2 divided by x. We are going to get minus 6x. That is x minus 1. Now with this, we use the minus 6x to times x and times 2. Minus 6x times by x, it will give us minus 6x squared. Then minus 6x times by 2, it will give us minus 12x. Now we subtract again. Minus 6 minus 6 minus 6 minus 6, this will give us minus 6 plus 6, which is equal to 0. 0, 0. Now with 0 here, now we are going to have 0 here. Now this one is 2x minus 12x. 2 minus 12, this will give us 2 plus 12, which is equal to 14. So we are going to have plus 14 plus 14x. Now this minus 3, we bring it down. The one that we did not perform any operation on it, we bring it down. Here we did not do any operation with these two, so we brought them down here. Here we performed an operation with this one, but no operation on 3, so we bring the 3 down, minus 3. Now looking at this one, now it's going to be, we are going to divide again. 14x divided by x. 14x, what we have now as our dividend is 14x minus 3. The divisor remains the same, x plus 2. Now 14x, already we have, what we already have on top is x squared minus 6x. X squared minus 6x. So 14x divided by x, we are going to get plus 14. The x will cancel x. Now 14 times x will give us 14x. 14 times 2 will give us 28. This is plus. Now we subtract again. 14 minus 14 will give us 0. Minus 3 minus 28 will give us minus 3 minus 28. This will give us minus 31. Minus 31. So we are going to have minus 31. Now we cannot divide again. X cannot divide minus 31. So this becomes the remainder. Now we can write it as this quotient, remainder this, or sometimes they may want us to put it together. If we want to put it together, we write the quotient, then write the remainder and divide it by the divisor. So what we are going to have is x raised to power 2 minus 6x plus 14. This has minus here, so minus 31 over the divisor, x plus 2. If you like, you can evaluate this to simplify it further. We can also leave it this way. We can write it as the quotient, then remainder the one that is remaining. So this is the answer. This is the answer to this. Example 2. If we have example 2, if you have 3 if you have this one now, 2x minus 2x raised to power 2 plus 3x raised to power 3 plus 5, then divided by x raised to power 3, x raised to power 2 divided by x raised to power 2 minus 1. Now if we want to divide this one, now look at what we are going to do. First of all, solution. Looking at this one, we have to rearrange it in the descending order of their degree. So this raised to power 3 must come first, followed by the raised to power 2, and then the 5. So we are going to have, in the brackets, we rearrange it to 3x raised to power 3, 3x raised to power 3 minus 2x raised to power 2 plus 5 divided by x raised to power 2 minus 1. Now again, here we are lacking something. We are lacking x, that is the term with just x raised to power 1. So we have to include it, x raised to power 1. We must include it by introducing 0 as the coefficient of the x. So this will become, it will eventually become 3x raised to power 3 minus 2x raised to power 2, then plus, we use plus 0x plus 5 divided by x raised to power 2 minus 1. So this is now the complete terms for the dividend. Now for the divisor, we still have to do something. We still have to include the x degree. That is 1 x raised to power 1 degree. We come back to this one, so we work on it again. It will become in the box x raised to power 2, x raised to power 2 raised to power 2 plus 0x minus 1 x raised to power 2 plus 0x minus 1. This is the divisor. Remember that here we have x raised to power 2 minus 1. The terms are not complete because all the degrees that are supposed to come after the degree 2 are not here. We are missing 1. X raised to power 1. After 2, we have 1. But the 1 is not here. So we have to put it just like we did for the dividend. So that is this. Now we put now the one we've gotten for dividend, which is 3x raised to power 3 minus 2x raised to power 2 3x raised to power 3 plus 2x raised to power 2 plus 0x plus 0x plus 5 plus 0x minus 2. This is minus 2. 3x raised to power 3x raised to power 3 minus 2x raised to power 2 plus 0x plus 5. Let me write it down here. Plus 0x plus 5 plus 5. I just want to make sure that everything is in this straight line. So let me have x squared plus 0x minus 1, then 3x raised to power 3 minus 2x raised to power 2 plus 0x plus 5. Alright, now we start our division. We pick the highest power in the divisor and use it to divide the highest power in the dividend, which is power 2 in the divisor and power 3 in the dividend. 3x raised to power 3 divided by x raised to power 2. That will give us 3x, that is x raised to power 3 minus 2. 3 minus 2 as the power according to the law of indices. So with this now, we use the quotient to multiply the divisors. We are now going to have 3x raised to power 3. Now 3x times 0, that will give us plus 0. Now 3x times minus 1, that will give us minus 3x. Now this 0, look at this thing. The 0 must be under 2x raised to power 2. Times this, we have 0. Now this times this, we have 3 minus 3x, 0 minus 3x. Okay, so we now subtract. 3 minus 3 is 0, minus 2x raised to power 2 minus 0 will give us minus 2x raised to power 2. Now the one that has power 1 is under power 1 here, so we have 0x minus 3x. 0 minus 3, this is minus 3. 0 minus minus 3, 0 minus minus 3, this will give us 0 plus 3. So we are going to have plus 3 plus 3x. Then we bring the 5, which we did not perform any operation on it. We bring it down, plus 5. Plus 5. Now, we take the highest degree here again. In this answer we got here, we look for the highest degree, which is 2s raised to power 2. We divide it again by the highest degree in the divisor and continue until we cannot divide again. That is now 2s raised to power 2 divided by x raised to power 2. The x raised to power 2 will cancel itself, so we are going to have minus 2. Now minus 2 times x raised to power 2, we are going to have minus 2x raised to power 2. Minus 2 times 0x, we are going to get minus 0. Minus 2 times minus 1, we are going to get plus 2. We are going to get plus 2. And so we now have this. We do our subtraction again. Minus 2 minus 2 minus minus 2 minus 2 minus minus 2. The minus that this one carries, you have to put it inside brackets to show that it is not the major minus that we are working with. We are subtracting, that one is minus on its own. Why this number carries minus, so we put this one inside a bracket, so it becomes minus 2. Minus times minus is plus, plus 2, now which is equal to 0. So this becomes 0. 3x minus 0, this will give us plus 3x. Anything minus 0 is the same value. Now this becomes 5 minus 2, which is equal to 5 minus 2 is 3 plus 3. So we are now going to have this. Now we cannot divide 3x. The highest power in this one is 1. We cannot divide 3x by x raised to power 2. Higher degree cannot divide smaller degree in polynomial. So once we get to the point that the power of divisor becomes higher than the highest degree in what we want to divide, we stop from there. We stop there and write that one as the remainder. So because we cannot use degree 2 to divide degree 1, we stop here and this becomes the remainder. So our final answer is going to be this quotient then and this remainder. That is, the quotient is 3x minus 2, then this is plus the remainder 3x plus 3, then this divided by the divisor, the original divisor, so we just put it as x squared minus 1. If you like, we introduce the 0x, but that one doesn't make meaning. Again, it doesn't change anything because we don't want to perform any arithmetics with it. So if we want to write the final answer, we can remove the 0 that we introduced. So this becomes the answer. So in this class, we have learned that for us to do division, we have to arrange the terms in the polynomial according to the descending order of their degree. Then we do our normal division, followed by multiplication, and then the subtraction. So that is how to solve advanced examples or advanced solutions of polynomials involving their divisions. Thank you.